Hello friends, this is Dr. Irfan Kamruddin Andani. We all know that there is gradual transition from primary dentition to permanent dentition, and during this transition phase we come across so many phenomena and mechanisms which nature has provided. In our last video we already discussed about the ugly duckling stage, and today we will discuss early mesial shift, late mesial shift, and what is leeway space. To understand all these, we must know first that what kind of occlusion nature has provided to us in permanent as well as in primary dentition. When we talk about permanent dentition, class 1 occlusion that was given by Edward Engel is considered to be normal and ideal. Why that much importance has been given to molar relationship? The answer is that when molar is in class 1, you can see that canine is also in class 1 position, that is upper canine lies in between lower canine and first premolar. And when canines are in class 1, there will be normal overjet and normal overbite if all the teeth are aligned and there is normal angulation of incisors and there is no Bolton discrepancy. But when, due to mandibular deficiency or maxillary prognathism or just a dental kind of problem, if upper molar is ahead by 3 millimeters, we call it half cusp or half step class 2. Here you can see that canines are also 3 millimeter ahead, and that has resulted in increased overjet, which must be at least 5 millimeter, because 2 millimeter was normal overjet when you had in class 1, and now 3 millimeters incisor also has moved forward, so you will get 5 millimeter overjet here. Sometimes the discrepancy is more severe and upper molar is around 6 millimeters ahead of the normal relationship to the lower molar. We call it full cusp class 2 or full step class 2. Here you can see that canines are also 6 millimeter ahead of its normal relationship, and it has resulted in increased overjet by 8 millimeters at least. On the other hand, if there is mandibular prognathism or maxillary deficiency or maybe just a dental problem and lower molar is 6 millimeters ahead of the upper molar, that results in reverse overjet by minus 4 millimeter. The reason is same, that 2 millimeter was normal and lower incisors have moved 6 millimeter ahead of the upper, so 6 minus 2 millimeter results in 4 millimeter reverse overjet, and this is class 3 malocclusion. Now let's talk about the features of primary dentition. The most prominent feature of primary dentition is generalized spacing, which is found in 70% of the population. But sometimes you can find closed dentition, which is found in 30% of the population according to one study. Among these generalized spaces, there are two areas in which these spaces are very much prominent. We call them primate spaces. These spaces are found distal to the lateral incisor in primary dentition in upper arch and distal to the canine in primary dentition in lower arch. This also has so much significance. Now here you must say that hats off to nature that it has given primate space distal to the lateral in upper arch, because you know that permanent incisors are much wider as compared to the primary incisors, and to accommodate wider teeth, nature has provided space anterior to the canine in primary dentition in upper arch. And what is the use of space distal to the canine in lower arch in primary dentition? We will know in upcoming slides. One more feature in primary dentition is the uprighted incisors as compared to the permanent incisors. Permanent incisors are usually more inclined labially. You can also see here primate spaces mesial to the canine in upper arch and distal to the canine in lower arch. What about the molar relationship? Again here in primary dentition we find three kinds of molar relationships. But the difference is that in primary dentition we consider distal surfaces of the molars, that is E's or primary second molars, and our classification is based on the distal surfaces. When distal surface of the upper E is in line with the lower E, we call it flush terminal plane, which is found most commonly and in 76% of the population, and it has the tendency to be converted into class 1 or sometimes into half cusp class 2 relationships in permanent dentition. Other kind of relationship is the distal step, which is very much similar to the class 2 occlusion in permanent dentition. That is why it can result in class 2 full cusp or half cusp in permanent dentition, and this is found in 14% of the population. Third kind of relationship is the mesial step, which can correspond to the class 3 relationship in permanent dentition, and sometimes it results in class 1 or class 3 in future permanent dentition, and it is the least common type of relationship found in just 10% of the population. By now we know that most common kind of relationship is the flush terminal plane. So the question is that how does it transform into class 1 molar relationship in permanent dentition? Here you can see there is flush terminal plane and permanent molars have not been erupted yet. According to the normal sequence of eruption, lower first molar erupts before the eruption of upper first molar, and when there is eruption of lower first molar, it pushes D and E into the primate space. You can see that primary space or primate space has been closed. That was the reason why nature has provided primate space distal to the canine in lower arch. This is known as early mesial shift, which is found in spaced dentition. When permanent first molar erupt in maxillary arch, the relationship in permanent molar is more towards class 1 now, and the flush terminal plane has been transformed into mesial step. But this is only possible in spaced dentition. But what about closed dentition? Does nature has any other solution to convert this ends-on relationship of permanent molar to class 1 position? Remember that lower molar has to be moved mesially 3 to 4 mm at least to get converted into class 1 occlusion from this ends-on relationship. From where do you get this space? Here comes the role of leeway space. You can easily visualize that the mesodistal width of permanent 3, 4, 5 in lower arch is much lesser than the mesodistal width of CDE in the same arch. So when primary CDE are exfoliated and 3, 4, 5 have been erupted, you get additional space. Same is with the upper dentition, but not to that much extent. So these remaining spaces are known as leeway space, which is more in the lower arch as compared to the upper arch. So how would you define Nance leeway space? It is the difference in the combined mesodistal width of permanent canines and premolars and the combined width of primary canines and molars. This difference is more in lower arch as compared to the upper arch. That is the reason there will be more mesial movement of lower molar, and in this way you can get correction of this ends-on class 2 relationship of permanent molars to class 1 relationship. According to Profit, the leeway space in upper arch is around 1.5 mm and in lower arch it is 2.5 mm, but in other books you will find these values around 0.9 mm in upper and 1.7 mm in lower. Don't go on the values, but you can see that the difference in the upper and lower leeway space is around 1 mm, and that results in late mesial shift of molar into this leeway space. Now you can see that there is some improvement in the molar relationship. We call this movement as late mesial shift, but still the movement of lower molar is not 3 or 4 mm. It was just 1 or 1.5 mm more as compared to the upper molar. So the correction of molar relationship is not 100% still. So is there any other mechanism? Yes, we do have. It's mandibular growth. We all know from our knowledge of growth and development that mandible continues its growth even after the cessation of growth in the maxilla, and this also moves the mandible along with the mandibular dentation around 2 mm. So you can say that late mesial shift plays role around 50%, and 50 to 60% mandible grows more than the maxilla, and that also causes the correction of ends-on relationship and transform into class 1 proper molar relationship. I hope I have cleared all these concepts of early mesial shift, Nance leeway space and late mesial shift, and what is the role of mandibular growth in the correction of flush terminal plane and its conversion into proper class 1 molar relationship in permanent dentition. Thank you very much for listening.